Our Lunch and Learn series is every third Wednesday of every month, and we have everybody from artists that we're showing at the moment to cultural leaders, people of merit to come educate us, so hence Lunch and Learn. So thank you all for joining us. Today, part of our Contemporary Textile show, we have Jovencio de la Paz. Jovencio de la Paz is an artist, weaver, and educator. Their work explores the intersection of textile processes such as weaving, dye, and stitch work, as they relate to a broader concerns of language, histories, and colonization, migrancy, ancient technology, and speculative futures. For example, the work that's in Contemporary Textile follows, which Jovencio is going to go into more detail during their talk, goes into a 1940s mathematician, Barcelona. So, very interesting. Jovencio received their BFA at the School of the Art Institute in Chicago and their MFA from the Cranbrook Institute in technical training at the Fondazione Arte della Seta Liceo in Florence, Italy. Jovencio works in a space between digital technology and hand weaving, focused on creating specialized design software, which they'll talk about today. Jovencio collaborates with algorithms, sub-generating patterns, and computational creativity to explore the related histories of technology and the loom. The resultant textiles hand-woven on a computerized thread controller loom, hence a TC. I believe you'll be referring to the TC today, so that's what that acronym stands for, the thread controller. Display a tension between the physical world and the digital, the organic and the technological, and the haptic quality of cloth versus the perceived rigidity of the numerical. Jovencio's work has been included in many exhibitions at institutions such as the Katzen Museum of Art in DC, the Museum of Craft and Folk Art in Los Angeles, Seoul Art Center in Seoul, South Korea, the Smart Museum and Hyde Park Center in Chicago, as well as Three Walls in Chicago. Jovencio is represented by the Holding Contemporary Gallery in Portland, Oregon. Please help me welcome Jovencio de la Paz.
Hi everyone, it's great to be here. It's always so funny to hear my life summed up in a few sentences. I am going to talk to you today about my work, of course, as a weaver, but I also want to talk a little bit about my influences, sort of my research, things that influence what I make. And also, I'll talk a little bit about technology and textile. And I think that the sort of subtitle of the show is Sewing, Tradition and Textile and Technology. And I think that that's like right up my alley. It's something I think about quite a bit. So this is the piece that is in one of the pieces of mine that's in the exhibition. I'll talk a bit about it a bit later, but I did want to say that when you reached out to me to be part of this show, I had the opportunity. I was at a residency in Ohio where I was weaving really, really large-scale textiles, and I was so happy to be able to make this piece specifically for this show and for the Art Center. So it's really a great joy. I haven't seen it before fully on the wall, so today was the first time I saw it completely installed. I think a lot of people maybe don't know this, but the loom, the weaving loom, is often considered like the first computer. In many ways, if you've ever seen a loom working, or if you've ever been around, I've seen videos. There's a really great video of weaving that I can share with you, of me weaving. I can share with you later if we have time. But the way a loom works is you basically program into it various patterns. And what makes it like a computer is that the machine can remember those numbers, right? So if you think about like a very simple calculator, all it's doing is it's storing numbers, numerical data in its memory, and we as the users, or the people utilizing the calculator, we can draw back out those numbers. So this sounds like a very simple idea, but actually in human history, that's kind of revolutionary, right? We could only remember things by using our brain power, writing them down, but the computer allows us to store large amounts of data in it, and we can sort of withdraw it whenever we need it. And the loom does a similar thing. So we put in very specific patterns, which are like numbers, and we can access those numbers over and over again to create the patterns that we're interested in working with. I'm a science fiction fan. In another talk I give, I talk a lot about Star Trek, and I was in Virginia quite a few years ago at a craft conference, and the keynote speakers, they did like special effects for science fiction, television, and movies. They like worked on Star Trek, and on the Enterprise, and X-Files, making props, making monsters, but also they had this interesting job of set designing the artwork that is in people's offices in the future, which I think is very interesting. It's sort of like we often talk about art being about representing the moment or our present moment, but their job was to imagine what art would look like in the future, and I loved that as a project to work on. So I was really inspired by that, and I made a series of weavings. These are all digital and hand woven, so I design the pattern on the computer and then weave the cloth on the TC2, the thread controller loom. And so what I did was I found descriptions of textiles in science fiction novels, and I wove them based on those descriptions. So this is actually in a show in New York right now. This comes from a really great science fiction novel called The Dispossessed by Ursula Le Guin. So she describes this tapestry in a space shuttle moving, at light speed through the solar system, and there's a kind of a reference, a pun there, a weaving shuttle and a space shuttle. So I made quite a few of these. This is another textile from a science fiction novel. This is from a description of a tapestry in Philip K. Dick's short story, The Last of the Masters, which is a story sort of about in many years, hundreds of years in the future, people have forgotten how to make things. Everything is made by machine and by computers, and there's one last weaver alive, and so that was a very kind of powerful idea. I think we are constantly faced, I think, more and more with automation, with machines taking over people's jobs, and so it's kind of a poignant piece. I had the really great opportunity to show that piece. I'm not sure if you can see so clearly. This is the governor's office in the state of Oregon, and it was just, they have contemporary artists show their work in this space in the governor's office, which was a really great opportunity for me. And it's kind of in this interesting frontier, they're very interesting sort of Oregon frontier kind of aesthetic. But so it was in the background on the wall, and there was this very interesting vitrine, this display in front of it, which there's a really long description about it in these plaques, but I'll read you what it says in the plaques. This vitrine, which is lined with gold leaf and silk cloth, contains fragments of the lunar surface collected by American astronauts Buzz Aldrin and Neil Armstrong during the Apollo 11 mission. The 4 fragments weigh about 0.05 grams in total. Included in the display is a diminutive synthetic fabric representation of the Oregon state flag, which traveled to the moon with the crew of the Apollo 11 for this specific symbolic purpose. The lunar rocks and flag were given to the state of Oregon by President Richard Nixon in 1969, and similar lunar sample displays were gifted to all 50 states of the Union as well as all countries recognized as legitimate governments of the world. And then this other plaque reads, "This fragment is a portion of a rock from the Taurus Littrow Valley of the Moon. It is given as a symbol of the unity of human endeavor and carries with it the hope of the American people for a world at peace." So a very lovely, like beautiful kind of a very idealistic kind of gift. But I always think that so much of our technology is filled with a lot of our biggest ideals, right? We sort of think about, the answer to so many of our problems today will come from technology. And so it's full of our ideals. But also, I think, it's simultaneously always filled with kind of danger. Like there's always a threat, I think, built into technology solving our problems, right? And as you know, so like going to the moon is like the height of all sciences and technology in the US up to that point. But we didn't go there for world peace, right? We went there to show the Russians that we were superior nation technologically. So, right, our ideals in our technology, but also kind of destruction or a threat of danger. So I was very happy to have my piece near these these objects which went to the moon. It gave me a lot to think about. And I think it's so interesting that textile, like our flag, traveled to the moon, and the sort of symbolic and complicated reasons for including that kind of symbol. But let me step back a couple hundred years in terms of technology. This is an etching of Joseph Marie Jacquard, who was an inventor and industrialist in England. And he helped produce this very important piece of technology, which really ushered in the Industrial Revolution. So at that time, the demand for cloth and textiles was really skyrocketing. But up to that point, we were still sort of weaving in this very slow, those of you who've done any weaving or really work with any kind of sewing or textile, it's super slow. So he was like, oh, we can industrialize this. We can meet the demand by replacing that handwork with machines. And so he had this really brilliant insight. And he also, I think it's important to say that very few innovations in technology just come from one person. There are a lot of other people who don't really get recorded in history, but he came to this really great kind of observation that you could translate weaving patterns into punch cards. And what that means is wherever you see a hole in the punch card, that means a thread on the loom can come up. And then when there's not a hole, the thread has to stay down. And so this is like I was saying earlier, embedding or putting information out of human brains. Like we don't have to remember the pattern anymore. The machine can remember the pattern for us. And so this is what his loom looked like. This is an example of a Jacquard loom in Massachusetts. You can see the punch cards are up here. They get fed into like this brain, this computer brain. These cords are what pass through one of those holes or don't get to pass through, and that's what controls the weaving threads to produce really complex patterns. And this is happening super fast, right? It's like, I think for a lot of us when we are in our studios or at home weaving or sewing, it's very quiet and let's say, quiet sort of process. But this is like industrial production. This is loud. This is powered by steam. It's moving super fast. Really, if you ever get a chance to go, I love going to factory tours whenever I get to, and I got to see Jacquard looms like this in Italy. And when they're going, it's like, this is industrialization. This is a big leap forward for our society. And so I, every other summer, except this past few summers because of COVID, get to I teach weaving at the University of Oregon. And we get to bring students to a place called the Licio Foundation in Florence, Italy, which uses these 17th and 18th century looms. So we punch our own we design our own patterns, we punch our own cards, they get fed into these looms, and the students get to weave on them. It's really amazing, it's great fun. But you can see how complicated some of these patterns are, right? So each card has to be punched on this, it's very aerobic. It's almost like a bicycle. You're just like putting in the cards, it gets punched, you pull them out. And it's very hard work. You know, it's definitely like, it's like a factory. You know? And it's really cool. These are incredibly heavy, these stacks of cards. And so the whole architecture, this sort of 17th century, used to be a monastery. They redesigned it with all of these ramps, so you can push these cards up to the machines. It's very interesting. You know, I think we're often so disconnected from seeing how things are made in our lives. You know, so seeing all this happen was, I think, you know, it's inspiring for me. It's also inspiring, I think, for the students. And you can see here those cords. They're like going up into the cards. If you have any questions about this, you know, I think we're kind of an informal group, so please just shout out questions. We'll have time for questions at the end also. Very complex, right? There's so much, it's such a precise master sort of craft, and we were really lucky to work with some of the foremost designers who use this kind of technology still today. You know, of course, this is a super rare kind of weaving. Most of their clients are like the Kremlin in Russia. They made wallpaper textiles for John F. Kennedy in the White House. So really, this is like $5,000 a yard, silk and gold, really high-end fabric. And here I am with my with my cards, very happy. You can see that the students' patterns were a lot simpler than others. And here you can see how this works at the loom. So the brain or the computer of the loom is up high, and you're sort of like down low, and it's very cramped and loud and. Yeah. But I tell you all of this sort of as a way to talk about modern computers. So as many of you might know, IBM's first computers, this is the IBM 100, these were all run through punch cards also. I don't know, some of you may be familiar with that, others it might be new, but so, do you really? I'd love to see those. So in the 50s, not that, maybe half a century after Jacquard, IBM realized that, we can use that same technology, that same idea of the cards remembering the patterns and the numbers, and we can adapt that for doing computer programming, right? So there's this direct connection between the Jacquard punch card, which you can see here, and the early IBM punch card. They're basically identical in their function. So this connection, I think, between weaving and our modern computers is really strong, right? It's sort of one technology, the loom, sort of allowed for the technology of the computer. And I think this is a really interesting tidbit of history, for me anyway. You know, I did not enter art school thinking I would work with computer technology. I was like a painter, a weaver. I was very material, dirty hands, material oriented, and learning about this relationship really just sort of opened up my mind. It was at the same time that the school in Chicago I was studying at bought this very important loom, this TC2 Thread Controller 2 digital Jacquard loom. So we were all just sort of exploring this connection between handwork, working with the hand, and working with the computer. So it was a very exciting time. Of course, today, our phones and our computers don't have punch cards in them. They have computer chips. But a computer chip works in exactly the same way. It's all binary code, right? 1 and 0. In the punch cards, 1 is represented by a hole and 0 is represented by a blank space, right? In the computer chip, 1 is represented by a blink of electricity and a 0 is represented by no blink of electricity. Of course, in the computer, it's happening at lightning speed, like much faster than a weaver at the loom. But it's the same sort of principle, right, over the decades. So, I was getting very interested in this idea of, when you're new to using any tool, I think you sort of start at the basics. You figure out, oh, how do I design a block if I'm a quilter? And then once you learn that a bit, you can break those rules and start exploring. So, I was spending a lot of time learning how to use the technology. Eventually, I came to a point where I was like, I want to break some rules. I wanted to sort of try my own thing. Now, these digital looms, which you buy, they're usually they're very expensive and they have very, very strict parameters. Like you can only do certain things, or you might mess up the machine. But I was really interested in sort of pushing that boundary a little bit. And what tends to happen, and this is what happens with my students at the university, they'll have like a photograph of their hamster, for example, and they're like, I want to turn this into a blanket. And I'm like, oh yeah, great. I can show you how to take that photo of your hamster, translate it into binary code, into basically 1s and 0s, and then have the loom create that photo. And you stand there and you weave the blanket of your hamster. But for me, that was a little bit limited. I didn't want to always rely on like taking a photograph or making a drawing or these sort of maybe more traditional ways of designing something. So I decided to write my own software, and this was a huge leap for me. It's just sort of like, I spend most of my time working with technology that's like thousands of years old, and so I was about to make this leap into how do I write software for this computerized loom. So I did the thing where you go online and watch YouTube videos. That was helpful to a point. Then I have some great friends who are computer programmers. They tried to help me a bit, and I sort of pieced together from all of those different sources how to write very simple design software. It's like I'm an amateur, and I love the word amateur. I love, like amour, right? It's like you do something because of love, not because of you're a professional or it's your career. So I think I'm an amateur computer programmer. So I wrote this software, this very simple software. I won't go into this one too much. It's one of the first softwares I wrote, but the textiles that came out looked like this. I know it's kind of hard to see on this wall. They're very, very detailed. But basically, I started giving the computer less and less of my own designs, but rather started using algorithms and sort of patterns that were generated in the computer itself to create textiles. And so this is a little bit different, right? I'm not giving it an image to weave. I'm giving it kind of a suggestion or an instruction, and it sort of creates the patterns on its own. And like really weird things come out. So like this is, this is a very simple program where I'm sort of drawing one line, and the computer is like trying to match the line I'm drawing. So as I'm doing this, it's turning my drawn line into thread, kind of at the same time. So, it's in some ways, I'm giving up a little bit of creative control to the computer. It's more like a collaborator or like a partner in designing these things. And so this is a show I had in Seattle. My work is very hard to photograph already, so I know it looks like a lot of nothing. But there's a lot of detail in these. A lot of, it's almost like when you look at this, and I know this is also a more and more rare experience, but when you used to look at a TV and there was like snow, like white noise, that white noise on your TV was like background electronic waves of the universe. And so I often feel like it looks like that. It's sort of this stuff happening inside the computer that's being captured in thread. The other cool thing I tend to find is my expectations of what the computer is going to do. When you're working on the computer, everything's really neat and tidy, But when you get to the studio, get to the loom, and you're actually working with thread, stuff goes crazy. It's never what I expect it to be. And really cool things emerge in that process. So, the thread is not flat, unlike the computer screen. Thread is it's like sculptural in this very microscopic scale. And because of that, the surfaces, they become like holographic. There's all of this, when you move around them, they change color because of light and shadow. So. This is always an intense segue to make. So after I wrote that first piece of software, I began reading up a lot about just the history of computer programming. And I came to this really interesting story, which just dug into me so deeply, I couldn't let it go for a lot of years. And I still haven't let it go. But, again, the bomb, one of the it's like going to the moon, right? The amount of engineering that went into creating this kind of most terrible device used the height of our collective knowledge about physics, about chemistry, really the height of technology. And an issue that came up was that we didn't really know what would happen if we set this off in Los Alamos. And so the government was like, okay, this could destroy everything. We need to find a way to figure out more precisely what's going to happen. And so they asked computer engineers at the time, in the 40s, to design a supercomputer, the most powerful computer to calculate exactly the blast yield of the atomic bomb. So they designed the computer. It's in New Jersey. It's at a place called the Institute for Advanced Studies. Very, very, very one of the most powerful computers at the time. It's 0.5% as powerful as your iPhone. But it did the job. They're like, okay, it's going to be massive destruction, but it's not going to destroy the world. Great. So they solved the problem. And this is the computer. This is the Institute for Advanced Studies computer. I always like to point out that most of the people who did this work were women. I think this is a part of our history that we're just now starting to acknowledge, the role of women in science. So often, it's a really we think of science and technology as a very male-dominated field, but some of the original programmers of these most powerful computers, these engineers and physicists, were women. So I think that's very important to acknowledge. When they finished the computer, basically the government was like, okay, we don't need it anymore, so you guys can just have it and do what you want with it. And so these folks were like, well, we have the most powerful computer in the world. We should open it up to the scientific community and ask people, what are your big unsolvable questions? What are your big questions that you need solved? Maybe we can help you. And so they chose a project by this fellow, Niels Al-Baracelli, who was a biologist, mathematician, and he was really interested in figuring out or modeling how single-celled organisms survive and grow and build communities. Basically, his idea was maybe there's a way to talk about Darwin's theory of evolution in a mathematical way. And so they chose his project, and he went to New Jersey to figure out, can I actually model how life survives, how single-celled organisms survive. So for me, this one computer had two projects. First, to create the most destructive force our species has ever endeavored to create, and then to understand the origins of life. And that poetics just blew me away. Okay, there's something very, very important about these two projects being side by side. So this is his original paper and his software. I don't pretend to understand all the mathematics. So I worked with a computer programmer friend, a really amazing guy. His name is Michael Mack. He makes computer games. He read this paper and he was like, yeah, let's do something with this. And I told him, I want to grow a weaving. I want to not design a textile, but I want to sort of let the computer grow a cloth. And he was like, we can do it. And so from what I understand, in Baricelli's original software, these individual, they look like dots to you probably, they're numbers actually, and each number represents an organism, like a little organism, which they each have different personalities. Some are super aggressive and want to take over lots of space. Others are very passive, right, and get dominated very easily. Some just try and remain hidden, like they don't want to be part of a conflict. They just try and hide and work their way through. And for Baricelli, for the original scientist, he could only see this in printouts. He didn't have a laptop or a screen to see this happen, so he would see it come out in printouts. And that number, these individual little numbers, it's actually quite arbitrary. Actually, that number can look like anything. And so what we decided is, rather than have the computer show us a number, I replaced that number with a weave structure. So for those of you who don't know too much about weaving, a weave structure is like a tiny pattern that is what the loom understands as a design element. So we basically took the organism and dressed it in weave structure. So if you imagine, like, it's literally like it's this number, and we give it a coat or a shirt of that pattern. And what resulted was stuff like this. So this is at the loom, a little rectangle like this. This is one organism wearing a yellow weave structure jacket. Over here, there's one that's wearing a white. You can see that there are other sorts of colors mixed together. These are all like a colony of organisms wearing blue. So they were growing at the loom as I was weaving them. And for a long time, I was just like, this feels like, I think maybe most artists feel like there's one big project that you might do, or like there's one, this is like 4 years of research and development and programming and trial and error. I felt like this was becoming the most important thing I was working on, and I didn't know what to do with them. It's like, what are they? Are they blankets? Are they meant to be cut up and sewn into garments? Are they paintings? I had no idea. But it was really just, the work was so exciting to see the loom do, basically without my intervention, right, create these patterns. And you can see they're very physical, right? They're not flat at all. They're really dimensional and have all of this texture. So these were basically, I was making a lot of these and storing them. I wasn't sure what to do with them yet. And what happened later, a year or so after this, is what is in your gallery now. But I thought I would show you, if we have time. How are we doing on time? Okay. I thought I would show you really quickly what the software actually looks like, so maybe you get a sense of what I'm looking at when I'm working. These are all just samples and tests. So this is another example. So this is a very different kind of pattern structure, right? It's not a multicolor structure, just one color. But let's see. So a section like this little square, this is one organism wearing its particular structure. We called, but my collaborator Michael and myself, we called the software BioLoom, and I'll show you what BioLoom does. So this is a software environment called Unity. It's used for games. It's used for making games and other things. This is what Michael is sort of an expert at. And so he took the paper from Baricelli's paper from 1950s and basically digitized it in a contemporary computer form. So the most kind of, well, let's look at Baricelli's original. So this is what Baricelli, what his software, his was in black and white, but we added color just for the sake of clarity. I don't know how well you can see that, but you can see it's basically a bunch of blocks and numbers. So each block and number is an organism, and it has certain personality. And so the first line down here is sort of like the most fair, everyone has a fair chance, right? Then each subsequent line, they start interacting with each other. So you can sort of read the generations of how these organisms are interacting. So you can see up here, number two got really maybe found lots of resources or was being really aggressive, and it starts to take over. And then number four is trying a little bit to squeeze in there, but it can't, so eventually number four dies off, right? Three, though, is doing a good job, like fighting number two, and so three becomes really dominant. These are like narratives, right? You can read like a story in there. And then eventually, though, three is doing a great job all the way up until here. And then what's interesting about this is it leaves a space, number two takes over everything except whatever's happening right here. So this is how the software sort of looked in its most classical sense. Did you have a question?
It reminds me of the snowshoe hare.
I can't quite hear.
It reminds me of the snowshoe hare and the northern, I think it's the lynx, but anyways, they don't go in cycles in the same way.
Oh.
The hare's population will
I see.
grow, the lynx population will go up, and then they'll eat too many of the hare, and then they'll...
Totally,
so
totally.
They have this oscillating cycle.
Yeah. I mean,
It reminds me of how they were coming to
yeah.
the other.
I'm quite an angler. I do a lot of fly fishing in Oregon, and reading about the sort of cycles that the lakes and rivers go through is similar, and also invasive species, how like entering one very simple change into this complex system can just override everything, So these are the organisms in their sort of original software. What we did is we said, okay, let's have you each wear a different outfit, and those outfits are all weave structures. So let's choose 8-ended satin. So same software, everything's the same, except we're making them look like weave patterns. So they come out like this. So this is what then the computer can the computerized loom can understand and can weave. So knowing that, you can sort of see again like that same narrative happening, right? It's like, these things are living their lives, in a computer blink of an eye, like thousands of generations. Look at one more. How about?
You ever make
Braille?
Braille out of that?
I totally could.
The kind of,
Yeah, absolutely. I'm gonna write that down. What's your name?
Carl.
Carl. We'll try it, and Carl, I'll send the Art Center an example of Braille.
You've done that?
No, I could do it,
Oh.
and they'll get in touch with you and show you what it looks like. I love that idea. So let's look. Yeah. Let's look at a twill. So this is another pattern. This was actually the one color, that white fabric I was showing you all. So it was great fun doing this, but still the question was, what do I do with these in the end? Where's my? I was really struggling to know what to do with these, and I was reading a book by a really great book. If you're interested, if after this talk you want to learn more, I really recommend a book by a fellow called George Dyson. He wrote a book called Turing's Cathedral. Turing, like the Turing test, Turing. And in it, he talked about Baricelli and his project, and he called it abstractions of Darwin's theory of evolution. And that word abstraction just also was like, oh, yeah, these are like paint, these are like, it's like, they're like abstract expressionists, they're like minimal geometric paintings, And if you read about the history of like Lee Krasner or Jackson Pollock, these sort of abstract painters, they talk about you have to abstract something from life. Like you can't just abstract something from nothing. Abstraction has to come from life. And so I love that. And it's like, these are alive to me, and they're abstractions of life. So I made them in this sort of painting format. And I think what happens is the audience gets to interact with them in a bunch of different ways. You know, they are kind of color fields and pattern, and but they're also this reference to how life unfolds in a really like precise, not metaphoric way, right? This software is about how life unfolds, and so that's sort of where my work is now. And so much of what I've been doing is you know, I'm getting back some of that creative agency in the composition and in the sewing and in the way that they're presented. They're presented with lots of space around them, you know, and I think that in some way I want to give these organisms who are experiencing, you know, I like to think they're experiencing love and war and hunger and all of these things which a biologic organism might. And so I want to give them space for that to unfold. And I think visually, it allows the viewer to sort of focus, because the visual information is so dense, right? Like what's happening in there is there's so much color and so much pattern. Giving sort of open blank space to sort of reflect, I think is important. So here's the piece that is in your gallery. These are like sister pieces. This piece is in the front room, and then the larger one is out in this main gallery. And they are from the same outfit, so to speak. It's a traditional Swedish overshot weaving style. And this was one of the first times I just could really see, you know, we tend to think of the computer as a really rigid and geometric and mathematic, but when expressed in weaving, like it's wonky and there's tension and all of these other sort of qualities of the physical come out, right? So, you know, at the loom, it's like, this is like a very large loom. All of this weirdness of life, you know, the computer space is like an ideal, very safe space, but the actual physical world is very unpredictable. And I think that's an important component of the work as well. You know, it's like I said, I feel like this project, you know, working with this software is a major part of my life now, and as a teacher of weaving has really opened up a lot of possibilities. Like now that I know how to write software, I want to write software that helps people make their patterns in a more intuitive way. Like I'd like people to be able to just draw directly into this digital loom. And so you don't have to go through all of these steps of taking a photograph, adjusting the photograph, etc. So I think there's opportunity there. But I guess I'll close in saying I, like many people, I think, I'm very concerned about our technological moment. And Carl Sagan, this sort of great scientist and writer, talks about being in like a technological adolescence. Our species is in a technological adolescence. And I don't remember, if you remember being an adolescent, it's sort of awkward, right? Like your body is like bigger than your brain thinks it is. And we're like that with technology. Our technology has just exploded so huge, we don't really know how to be in it, right? It's like taking over in a way that we can't control. And I think a lot of people want to answer that problem by saying we should reject technology, right? We should go back to just work with the hand, you know, sort of reject. And I'm for like putting your phone down more and going on more walks. Don't get me wrong. But I think actually what I hope my work does is sort of allow for a place where our relationship with technology isn't so passive, right? I want to ask questions about where did technology come from? Where did the computer come from? How does that relate to weaving, but also to the Second World War, to the lunar landing, et cetera, right? How are these things, how do we actively sort of understand the story of technology? And I hope that creates a place where we can ask more questions about these things, which are such major parts of our lives now. So thank you, and if you have any questions, any further questions, I'd love to answer them. Yeah.
I wish you could meet my son, because he's an engineer, and he lives in Albuquerque, works at San Diego, and does a lot of software.
Sure.
He's been using software, the language of Python. I was wondering what language were you
Yeah.
using with yours?
So Unity.
Unity,
Yeah.
That's not a part of Python, it's a different.
No, let's see.
I'm done.
Okay, me too. So,
He's smart, so.
I mean, it's just a different style. I guess I would describe it as a different workspace.
Okay.
So like, Python is like a,
So if I shared that with him, then I would,
yeah. Unity,
he would understand what I'm talking about.
yeah. Unity is very graphical. So it does a lot with graphics.
Oh, so what he's doing is putting, I can only explain it, but he puts in things and lets the computer make fractals.
Great. Yeah.
And so that's a repeating
Right.
pattern, and he's getting these beautiful
Totally.
patterns, and he's learning how to do it, and then he puts them on metal.
Oh, wonderful.
And so I wish you could get with him,
Yeah.
because I think it would really get very interesting for the two of you to
Yeah.
talk, and maybe you can get some, collaborate with him with his total wow ability to mess with software.
Yeah. I love, I never expected to be in this position, but it's so interesting when I sometimes I go lecture and there are like two distinct crowds of people that come. There's like, I should say three actually, artists, weavers and textile people, and then software engineers. And it's a really interesting, it's exciting to me to get these people together, because it's sort of like, oh, aren't we worlds apart? It's like, no, actually, this is all connected.
It's been really fun to watch him turn into the artist, whereas he's always been this engineer brain.
Sure.
So it's been really fun for me as the artist mommy.
Yeah. It's like at the highest, I'd say that as we work more and more with computer, like, I think that at the highest, science becomes like art, and art becomes like science, and music becomes like science, and and science becomes like all of those things. It's an inquiry about.
The more I talked to him as he went through his schooling, the more I realized that he's starting to integrate more and more. Like, he was just electrical engineering in graduate school, but then as he progressed, he seemed to be adding things like mechanical engineering and all kinds of different kinds of engineering.
Right.
And it exploded into all of it.
And I bet he's able to do that because of artist's mom. Yeah. Wonderful.
Did you ever study music? Or you have a favorite player?
Yeah, absolutely. I don't really bring this up much anymore, but before I studied art, I was studying to be a composer, and it's totally the same. Music as a mathematical language, right, can be expressed in, like, a player piano is exactly this. It's holes and no holes. So there's that is something. Maybe I'll give it a few years.
Fraction. Got the whole note.
Yeah.
You got the 16th note.
Yeah. Well-
It's like, then you wonder, okay, where does that fall on the line?
I mean, it's incredible the way that music. Like, I love that scene in Close Encounters of the Third Kind. I don't know if you remember that movie where the aliens, they can't understand. they can't understand any language except music, because music is mathematical, and yeah, so for sure. Any other questions or thoughts?
This was such a fascinating. I mean, it must be wonderful to live inside of your brain because you really, and also your practice really allows for so much to happen. It's not a question, but I really enjoy seeing this presentation and following your work, and also, but again, this wonderful balance that you allow to fluctuate. I think it even followed what you were talking about with the 2s and the 3s. You're allowing for different things to come in, for technology to come in, but also that you still have your control over it. And then also, I really enjoyed this presentation thoroughly. Thank you all for coming, by the way.
Thank you.
Thank you, Jovencio.
Yeah,
Thank you
you're
so
welcome.
much. Any other questions? Comments? And this will be on our YouTube channel eventually. Thank you so much.
Yeah, thank you.